Hello, welcome. We're just gonna jump straight into it. I hope you understand that I'm assuming that you know some Java. I'm assuming that you know you have some general understanding of how the Java robot projects work and how the FRC programming works. We're gonna be in this guide. We're gonna be looking at generating the project with Phoenix Tuner X, and then integrating visual measurements, so you'll be able to get position like this in the game, during the actual game. We need this because, like, for example, in a Reefscape, this is 2025, we want to align with a scoring place automatically, so our driver does not have to do this. So it's going to be half automatic tally-up. And for this, we need to know our position. Basically, how this is going to work is that we're going to be using LimeLight, which is, I would assume you've already seen it, but it looks like this. It's a black box, a bunch of connectors go into it. If you're not familiar with it, if this is your first time doing it, I would really recommend going FRC, Robotics Competition, and just reading through all of this. FRC wiring, mounting, they go through everything. Actually, yeah. So this advantage scope, it's not entirely. Actually, I guess I can play our position. If it will actually play. But yeah, it's a little bit messed up over here because I was messing with some settings. But in this case, this is how this is gonna look when you get everything working. This is still gonna be a little bit messed up because we had some issues, which are already fixed. So you'll be able to track your robot like this during the actual game, which is very nice. Allows you to do whatever you want. In this case, this is advanced scope. It just shows you a lot of stuff. I would really recommend just, again, getting started with this. It logs a lot of stuff. It does everything that you really need to know. It records everything that you really need to know. Very useful for analytics, for everything. And especially like this is going to be saved in your computer. You're going to know what you did that game. You have a replay, you have everything. Okay, so we are using Advantage Scope. Another thing that we're going to be using is Phoenix Tuner X. You need to have this. You're also going to need Balena Etcher, which is going to be needed for LimeLight update, and LimeLight. But once you got through everything, wrapping your head around it, or actually deciding if you actually want to do this, because I don't know, the first step in all of this, you would really want to update your LimeLight. I will link this. This is basically, you just select your LimeLight and then you follow those steps. It's really easy, it's really simple. And after you did this is where LimeLight Finder is going to be helpful to you. You're gonna, well, first of all, you would want to go in here and you would find LimeLight and you double click on it. And once you double click on it, you get into this. This is your basic, well, you would have a camera vision over here, but I'm not connected to the robot, so I don't get anything. You have a bunch of things over here, and we're not gonna mess with anything. Again, it's all in FRC starting competition, like FRC starting. Again, you should read through it, but once you read through that, you should go into this. I'll also link this down below, which is robot localization with MegaTag 2, introduced in 2024, so it's basically pretty new. Here's the upside to it. You can see the red one is the pipeline. Oh my god, it's MegaTag 2. And MegaTag 2, the best part about it is that it allows you to track your robot with just one April tag, which is so great, because in our case, what we're going to be using, there's only one April tag on this face, and we will want to align over here, so we would want to have as much information as possible. You can also see how just well it tracks, even though such a very long distance, and through like plastic things, because, but yeah, read through here, But basically, what this is going to tell you to do is to go into LimeLight, and then you go into configuration, and then you go into advanced, and this is the last thing that got pulled from a robot. But yes, as I said, there's only one April tag on the side that we're going to be able to see. Yeah. So you can actually see that yellow is mega tag 2, and green is mega tag 1, or mega tag 2. And the other way around, actually. Yellow is mega tag 1. You can disable, enable each one of them. Do whatever you really want. But the main thing that you will have to look at is mega field space localization. This field is a little bit messed up. I don't have a proper field yet. This is just like SketchUp. You can just see that all of the April tags are just in the air. There isn't actually a drawn field yet that will actually accommodate this. But specifically, you will have to set up LimeLight forward, LimeLight upright, LimeLight up. I don't know if this will allow me to load. Yeah, but once you do that, you'll see your camera move over here. It doesn't allow me to do it because I'm not connected to the robot. But with your camera, you will basically specify the position of the camera on the robot itself. Pitch, roll, and yawn. You will have to pull all of that up. That's in meters, and this actually needs to be 0, but this is in degrees. Specifies everything over here, meters, degrees. After you're done with this, specify your robot length width, your type, which is it's just actually for visualization. But yeah, after that, you can actually point your LimeLight to an April tag, and you'll start showing you something, which is not going to be really accurate yet, because I don't know if I said it before, but for mega tag 2, it assumes that you know your heading, your yawn. And that's what we're going to actually start with. We're going to be starting with setting our yawn. I don't know if I really need to go through this configuration, but if you're from our team, then I can tell you that we are using SDS MK4s with a L3 gear ratio. If they change the setup, everything is written over here. Yeah, so one really important thing that I want to point out is that you have 2 motors on here. In this case, those are Falcons, but in our case, we use Krakens. So there's going to be 2 motors and 1 camcorder. This is the small thing in the center of it. This one that is with a small gear and that connects to the center rod, you can actually spin the wheel and you will see what spins. But basically 2 motors. One is responsible for turning and one is responsible for actually going forward. You can see that this one with this shiny gear connected to the black gear, and that it goes down and it goes into the belt. This belt is responsible for turning. So this motor that is connected to the belt through the gear is our turning motor. And the other motor that is connected to this big central gear, which is actually not this one, it's that one over there, because you can see this one's connected to the black one. It's just the wrong photo. But yeah, this gear over here is connected to the central gear and it's connected to the wheel. You'll have to label that. You'll have to give them proper IDs, so you know. I drew them out, and I have the sketch with like all the labels, so I can easily look back and understand what motor is responsible for what, especially in the troubleshooting, will be very helpful. But if you filled all of this out, again, you need 8 talons, which are Talon FX is a controller that is on Krakens and Falcons. You'll need 1 pigeon. Pigeon gives us our yawn. Again, going back to yawn, we're gonna need it for our for our Mega Tag 2. And after that, Phoenix Pro. You'll need Phoenix Pro for our carnivore, because yeah, it's this thing over here. I hope you're familiar with it. I really hope so, because it's the heart of everything. This is how we connect to them. It uses CAN, but it uses CAN FD. You can see the CAN FD little thing over here. The benefit of that is it has a higher refresh rate, which allows for more accurate odometry. If you want to understand this better, I will link to this article over here. It's a great article. Even if you don't want to understand this better, I would really recommend reading this. They go into great depth about why we need vision and all this kind of stuff. But we can actually use this without vision, but we'll need to know the starting position somehow. So you would need to like square it off from something or do something like that. In this case, we're going to be using our vision to get our initial position, or actually any other positions. But let's get back to generating our project. I'm actually not connected to the robot, so I will not be able to do everything and go through all of this, but there's so many instructions. And basically once you finish with that step, this is where it's going to throw you. In this case, you'll have to select your motors. So left front control. I named control, but they're actually turning motors, which I just talked about like a few minutes ago. And then you have drive motor, which is, just to repeat myself for 15th time, the drive motor connected to the bevel gear, to the big gear in center. Control motor connected to this thing. So basically the motor that is with the thing underneath it, with this kind of rod underneath it, is the control motor. And yeah, and then you'll have can coders, because we can coders, and you'll be able to select a can coder. And then you have to calibrate encoder. Well, actually, whoa. That is too far. First of all, you'll have to do all of this. After you select all of them, you'll go and validate selection, and then you start azimuth test. For that, you'll have to enable your robot. That goes by, and after that, you calibrate your encoders, and then you go to verification. And then you just follow the steps. I mean, it's really that simple. And after that, you will be thrown into the you'll just, actually I can just click it, yeah. Put in 4373 for our team, and then you generate the project, and it's generated. At least in my case, I already finished it. So it's already a little bit modified. I accidentally started a little bit before. Yeah, and once you finish that, this is how this is gonna look. You'll have turner constants. You'll have command drive, which is actually where we will be working. I'm not gonna explain the rest of the structure of this. But basically, the first thing that we're actually gonna do is we're gonna go. I don't have that open. Oops. We'll have to go to LimeLight. Yeah, over here. So we're gonna search up FRC programming with LimeLight. I will actually link this, and we're gonna select. You can see the endings. So we're gonna select Java. This is gonna send us to their GitHub. We're gonna click on the latest release, which is this thing over here. Releases latest, and we're just gonna download this. I already have this downloaded, and I have too many of them downloaded actually. But after that's installed, you will just throw this into your main folder. In my case, I have to rename this because it just needs to be aligned with helpers. Right, great. You're done half the way. Actually, if you just start like after you exported the robot after you exported the project from CTIRE, if you just deploy it onto your robot and go into here, go drive state, and shove your pose in here, you will see the robot and it will move. I promise you will. Like, it's so dumbly simple. The only issue is that without LimeLight, it's gonna drift over time, and you don't know your position. So when you start, it's gonna just start from 0, 0 over here. But we all know that's not actually where you start. If you want to do this just purely blindly, again, read this article that explains the impact on odometry, meaning that how much drift it will have over time. You can actually just reset. There is somewhere, I promise you, there is a. I remember these guys had it in their code. Yeah. Yep. Okay, I mean, I cannot find where it is, but you can just literally call reset pose straight after exporting this. You can go and find the constructor for this, and then you can literally call reset pose, and then you'll have to create pose 2D, and then there is ways, you can just you can align basically with the field. So for example, if you don't want to do all of this LimeLight and you only need to know your odometry for the beginning, like for, let's say just for the auto-on, and it doesn't need to be very accurate, you'll understand it's going to drift over time. You can actually just like, let's say, align with this line over here and this side, and you'll have, and then if you will know this, like, yeah, you will not know this position, but you will need to calculate this position over here, and then you will convert it to pose 2D in meters and pass it in here, and call reset pose once in the constructor. You will have working odometry. It's not going to be very accurate, but it's going to be working. In our case, we already have a LimeLight, so we're just going to keep working with that. So the first steps, we're going to be defining our, I guess the basics, the real basics. So we already have a, I guess, pigeon defined, but we're going to do it again because it's just simpler to redo it over here and not go and look for it. So basically in here, we define our LimeLight helpers pose estimate. This, you can just literally just copy what it just did and it's gonna work. But we just create this thing which is gonna be our pose estimate. We're gonna update this periodically each time, and then we have to define our pigeon, because as I said before, you need to know your heading or your yawn for megatag 2, which is what we're using, because yeah. After that, the next thing is you're gonna go down into your periodic, and it's gonna be in here. You're gonna ignore this. This is, you don't need to send this, but it basically checks what alliance color it is. And here's the thing that you're gonna paste into here. Actually, boom. I'm gonna leave all of this code down below. I will actually leave more down below. But in this case, we call this library set orientation, and we tell it LimeLight name by default is just gonna be LimeLight. It's gonna be pigeon.getYawn, gets our yawn and gets it as a double, and the rest you leave at zeros, because it can take way more, but if you just leave it as 0, you will understand that you don't paste anything in. And after that, it's gonna do this periodically, meaning every 20 milliseconds. And oh, actually, yeah, ignore this. After you did this, you can deploy this robot to your code. Deploy your robot to your code. Deploy this code to your robot, and go to your LimeLight again, and go over here, go into advanced, and look at this field, and just point the robot to the field. If you did everything correctly, if you specified this, you'll see your robot just appear on the field, and it's going to be accurate. If you want to use just your LimeLight, and you don't care about odometry, which is, at this point, it's very easy to integrate, but you can use this. You can use this LimeLight position. And actually, the line that I just deleted before, just a few seconds ago, is actually how we get our position. So if you actually read through the code, I'm not entirely sure. Oh, where did it go? Yeah, over here. If you actually read through this, when they field orientation with megatag 2, it's actually incorrect, because they say WPI blue, but it needs to be megatag 2 for you to use megatag 2, which I really recommend. There is no downside to it. But yeah, at this point, that variable that we created up top will be refreshed every 20 milliseconds with the current position that LimeLight sees. You're mostly done. And then the only thing that you really have left is to paste this in. So I understand it looks really complex, but let me just simplify to you what it actually does. This is all it does. It just adds measurements, visual measurements, which is a function that's down below, and it's just pastes stuff in. So it's limelight.pose, so it gets pose2d from the limelight measurements that we got before, and it gets timestamp from the limelight measurements, and then it checks the timestamp like with our stuff, and just for that. But that's it. After you do this, you can actually just add this. The problem when you add just this, why we need the rest of it, is that when your limelight loses vision, it's gonna start reporting 0, 0. And if you don't have if statement which checks if the limelight sees sees an April tag, every time you lose vision, the limelight will keep reporting 0, 0, which means it's just gonna send you down here. So this whole thing is really just an if statement that checks if we get any input. We get X position from the pose2d, and we check if it's on 0, checking if limelight sees anything. And then if we do, then we send visual measurements to our pose estimator. And then I also put it to Smart Dashboard, which is which is very helpful. I would really recommend going through this and this. I'll link all this down below. But this is what we're doing. We're doing pose estimator. It's actually built in. It's like under skin. In this case, we don't actually interact with it. We interact with the CTRE interpretation of it. But that's it. That's really it. Just paste this in here. The reason for us having try-catch block over here, which is this thing, is that when we just start, we check if it equals null. The reason for that is that when it just starts, there can be a weird issue where it will crash your whole code if you don't put try and catch block over here. If you put try and catch block, it's just gonna try, and if it doesn't succeed, it's just gonna catch, and it's just gonna repeat. It's gonna report the error. But if you don't have this will literally crash your code 50% of the times. And it's really just everything just to check if we see something. At this point right here, congratulations, you've done it. Once you deploy this code, and once you go to your advantage scope, and you look at your pose, you will have pose of your robot. Yeah, that's done. The one thing that we missed, maybe, is that set standard deviations. You can really just look over here and read this. It's basically how much we trust our visual measurements. This goes not into periodic, because we don't want to call this every 20 milliseconds. We only need to set this once. But those are the values that are defined by, well, not defined by. Actually, we're going to use these ones because the previous ones are for megawatt type 1. You can just copy those values. They work fine. Basically, the less the number is, the more it trusts the LimeLight output relative to our wheels. So you can see when we set 999 for N3, you can look, and it says that 999 means that the less that it is, the less it trusts the visual values. So why we set it to 999 is because we want our values only to come from our pigeon, because our LimeLight values are actually dependent on our pigeon. So we actually want to completely ignore our LimeLight values for our yawn. And then we set 0.5, 0.5, which is like pretty confident level in our vision score. And yeah, at this point, this document will be linked. But I mean, I really think you can just copy this whole thing. If the document has changed, you will just need to find Add Vision again. But realistically, at this point, you deploy this, and you'll have a working 3D tracking. It's just that simple. And I mean, I can just show you how our robot. We had a little bit of weird thing because our April tag was placed in the wrong position actually. That's why you can see it jiggle a lot. But we know where we are. This is how it's gonna look. You're gonna be able to drive around. You will know your position. And yeah. And one last thing is that if you have any issues with any of this, I would really recommend going to Chip Delphi. I hope you're familiar with what this is. Chip Delphi is basically a big forum that is just literally made for FRC. Thank you for watching. I hope it all works out for you. The code, the GitHub repository is going to be left down below. Good luck. Best of luck with your season.